Today's topic is what we can refer to as standard deviation. This is sort of the big main idea in this whole unit. So today's lesson is actually the most important one. Okay, you really need to have a good understanding of what standard deviation is. And it's not that hard really to understand. I'm going to sort of show you with a couple examples. The textbook does a terrible job of explaining it. And so I've come up with my own little handout that should hopefully allow you to understand it. And the little clickers are going to be, you're going to be entering numbers to me to confirm that you actually get what's going on. So we'll have a lot of fun today. So it says here, although the mean, median, and mode are fairly easy to understand, everybody can usually understand them pretty easily, they do not measure how a set of data or a distribution varies. And when I say varies, what I mean is, are the numbers bunched close together, or are they spread apart? Are the numbers all consistent, or are they spread apart? Okay, and that's the big idea. Bob, you need to pick up a handout, one of those blue things, anyway. Here is the first example. Christina drives to school and can follow either the Brooks Expressway or the Kingston Expressway. She timed herself for 2 weeks and got the following figures. So on the Brooks, she did Monday, 15 minutes, 26 minutes, 30 minutes, 39 minutes, 45 minutes. On the Kingston, 29 minutes, 30 minutes, 31 minutes, 32 minutes, 33 minutes. Which one would you drive?
Kingston.
You would take the Kingston, Stephen. Can you explain?
Because the average is 31. And I said the average for the other one would be. You haven't looked at the middle. That would be the.
You're just looking at the middle one?
How the hell did you get here in 15 minutes?
Well,
30.
Bad traffic.
traffic jam, who knows? Maybe it was a holiday that day. Who knows, right? All right, well, it's consistent. That's good. That's good. Let's just jot that in there. So the Kingston is consistent.
And the Brooks seems to be getting worse.
And the Brooks, well, it does seem to be getting worse as the week goes on, right? But I may have put them in order. I maybe shouldn't have done that. But would we say that it is inconsistent?
Yes.
Okay. Okay, so what I would like you to do is I would like you to calculate the mean and median for each one of those rows. How do you find the mean? You add them up and divide by 5. How do you find the median? You put them in order and pick the middle one. So the first thing you're going to do is you're going to give me the mean of the Brooks, and you're going to enter the number with your clicker. The mean is the add up the Brooks and divide by 5. So go ahead and do that. Now that you've done the mean and the median, and I'll give you the answers right away, tell me which way is better, A or B? Brooks or Kingston? Multiple choice, A or B?
True or false?
Well, A or B.
I'm going
A or B. So I hit A or B.
Which one's when you press together? You
Press A or B.
A or B. Just say one. Are you sure? Oh, look at that. Shut up, Steve. A one. I don't know. I don't know.
Hey man, you're not waiting for me.
Okay, so what did you get, Stephen, for the mean of the Brooks? 30.
Hello.
What'd you get for the median of the Brooks? 30. They're both the same, middle number. Kingston, what was the mean?
It's 31.
It was 31.
Wasn't question 1, 31, 2?
Oh, it might have been. Yeah, I think you're right. I think it's
No,
31.
question 2 is 31.
No, question 2 is 30.
I think there should be 31. You're right.
Why is that 31?
So, in other words,
Because you add them together.
which way is better? Well, we've already agreed that the Kingston was the more consistent. In this particular case, okay, in the Brooks time, the time varied from 15 minutes to 45 minutes. The Kingston, the time varied from 29 to 33. Okay? So in both cases there, the averages were exactly the same. So it really doesn't tell you which one is the better way to go, which is the more consistent. Okay? We would say that the Brooks range would be how many minutes? What would be the range of the Brooks? You can answer that. That's question number 6.
It's just in between, isn't it?
What would be the range of the minutes?
We say that the first range. Isn't the answer right there?
It's a number, a single number. It's from 15 to 45.
So it's 45 and subtract 15.
29.
Yeah, I'm just trying to learn.
I understand.
30.
Okay, you know what?
The Brooks range is
Take a shot in the dark. 49 by 60. No, 30. I'm talking.
you do have it on your page too, don't you, Rowan?
Yeah, I guess we do.
Yeah.
The Brooks.
Okay.
Still got glasses. 30. I think it reads 90. Wait,
Okay, so you should have got, what was the Brooks range? 30 minutes. The Kingston is only what? The range is only 4. Okay? So you might say, well, we could just go with the range. That tells us which one is more consistent. But the problem is, well, hang on, let me just do this here. First of all, the range is the difference between the largest and the smallest. The range is useful in some instances, but it may be affected strongly by an extreme value. For example, let's say one day on the Kingston, let's say there was a traffic jam or it was snowing or something or other, and that 33 was, I don't know, a 52. Even though all the other numbers were 29, 30, 31, one day it's 52. The range, one extreme value, and the range is shot out of the water, right? So the range isn't particularly useful when you're trying to find out consistency. Okay? And that's what I'm talking about here. Suppose one day on the Kingston you got caught in a traffic jam, spent a whole hour. Even though all the other days were close together, the range would be very high. So the word variability refers to how spread out the data is. I like to call it the spread outness. In the above example, the Brooks variability would be very low or high. Now the Brooks, I always forget here, the Brooks was the inconsistent one, right? So the variability of the Brooks would be very high. In other words, the numbers are all over the place. You should fill it in, Bobby, on your handout. While the Kingston's variability would be very low. Low variability means all the numbers are what?
Roughly the same.
Roughly the same. Close together, Rowan. Good. Okay, so the number that we use, so the phrase that we use for this is the standard deviation. The standard deviation is a numerical measurement of a set of data's variability. It's a number that tells you how spread out the data is. It's a number that tells you how spread out the data is. A larger standard deviation means that the data means that the data is spread out or close together. Spread out. A large standard deviation means that the data is spread out. It's all over the place. It's inconsistent. It's spread out or it's equal to inconsistent. So big standard deviation means big spread outness. Low standard deviation means that it is close together. Very consistent data. Close together or very consistent. Okay? That is something you need to know. Big standard deviation means it's spread out. Low standard deviation means it's close together. Okay, so, Mr. Bennett, gee, it would sure be nice if there was some way for the graph calculator to determine the standard deviation.
That would just be dandy.
There is. Because trust me, you do not want to know how to do it by hand. In the good old days, back in the late 50s, Stephen, when I was a wee lad, and we had to figure out the standard deviation by hand. Not a lot of fun. Let me show you. Okay, so what do? You enter the data into your lists. So the first set of data is 15, 26, 30, 39, and 45. Might as well put the second one in there as well. 29, 30, 31. Oh, did I miss one? 32 and 33. Okay, so put the data in your list. Remember, these are two separate data items. That's why we go L1 and L2. You wouldn't put them all in one list. Okay, they're two separate pieces of data, right? Now we're going to go stat, calculate, one var stats. So stat, calculate, one variable stats, and we want the stats for L1. Okay? Second function 1. Second function 1.
Second function was with one.
I was just trolling you, man.
I know.
I'm lost.
You got that right.
Second function.
Okay, so what we've got here is we've got the one variable stats. I think I've already got them up here. Yes, I do. So you should have got, did you get an SX 11.6 and a funny looking OX 10.41?
No.
Okay. The value that we are interested in is this one here. That is the standard deviation, the one that looks like this. It's a sigma. It's an O with a sort of a line coming out the top.
With the X?
Yes. Okay. Yep. No, enter after L1. So the standard deviation for list 1 is 10.41. If you do standard deviation or one variable stats on L2, you should have got a standard deviation of 1.41. This is the Brooks. This is the Kingston. We already know the Brooks one was the inconsistent one, right? This is high standard deviation. The standard deviation is 10.4.
Now, if you want to see the Kingston one, you just type in L.
You go one variable stat, calculate one variable stats L2. Right. This one is low standard deviation, right? 1.41 is considerably less than 10.41. The Kingston is more consistent and it has a low standard deviation. It means the numbers are not that spread out. They are bunched close together. That's what it means. Does that kind of sort of make sense?
So what do we do for 7 and 8 on this thing, Jay?
Worry about the content, okay, Stephen? Do you understand what I'm talking about when I say standard deviation?
What is the definition of the standard deviation?
It's a measure of the spread outness.
That's all it is.
That's what it is. It's a number that tells you how consistent the data is. And I'm going to give you some more examples. Okay, so for example, in example number 2, this is question number 7. Which data set would you expect a higher standard deviation? If we took everyone's age in the class, the student age, excluding my own, if we took your student age, yes, that would be an outlier. If we took the student age and wrote them all down, and then we took your mark in the class, which one would you expect to have a higher standard deviation? Okay, so what did you guys say? Lacey, what did you say? Which one has a higher standard deviation? The student's mark? Yes, that is the correct answer. Whoa. B, this one would have high standard deviation, this one would have low. We would expect everyone's age to be in here. We would expect everyone's age in here to be relatively similar, 17 or 18. That's next year when you're back here, Steve. That would be a little bit higher. The student's mark in the class would tend to be
Lower.
the higher standard deviation because we'd have anywhere from
60 to 70.
well,
No, 51 to
lower marks to higher marks.
43. Yeah.
Okay, example number 3. Now you might say, Mr. Bennett, this is all fine and dandy, but this is just made up math mumbo jumbo. Who really cares about standard deviation?
Remember, they applied and applied math. Right?
Well, what type of products require a low standard deviation? Do we care about the diameter of oranges? Do they need to be consistent?
No. Yes. Yeah.
Do we care if we buy does it matter if you buy a box of oranges and some are tiny and some are big?
You buy for the weight, so it doesn't really matter.
Okay. What about iPod battery life? Do you want your iPod battery life, do you want your iPod battery to be pretty much the same as everyone else's? Yeah, because if you buy one and yours only lasts an hour and someone else lasts 2 days, you want them to be consistent.
Unless if you buy an iPod. Good ones.
What about the diameter of a bolt? Do you need that to be consistent?
Yes.
If it's a 1/4 inch bolt, it better be pretty close to a 1/4 inch, hadn't it? Bolt man. You know what, Steve? Let's try something. Let's try me talking and you not answering unless I include your name in the question. Okay? Bolt manufacturers, they are pretty concerned about standard deviation. When you buy a bag of chips and it says 32 grams, do you want it to be pretty close to 32 grams? Yeah. If it gets 37, you might get a bonus, but people would be kind of ticked off if you only got 12 grams. So Old Dutch, they're concerned with standard deviation. What about the amount of ibuprofen in a pill? If it's a 200 milligram pill, you better make sure it's pretty darn close to 200 milligrams. You want low standard deviation. Number of Cheerios in a box, does that matter? Yeah, not as much, right? But certainly all of these topics all have a certain amount of quality control built in. Companies that manufacture things are concerned about standard deviation. Okay?
Have you noticed that the chips, like you open them, half the bag is gone?
It's sold by weight, yeah.
I'm like,
Yeah. Any company that manufactures anything, whether it's iPod batteries to bolts to chips to ibuprofen, all care about standard deviation. It's an important thing. Okay, so my friends, here's a brand new one. This is question number 8. A machine packaging candy in 90-gram packages is thought to be faulty. A sample of packages is selected and the actual masses in grams are as follows. So it says 90 grams. The first bag only weighs 86. What is this machine's standard deviation, and is it faulty? So what'd you get for standard deviation? 1.8 or something, right? Okay. 1.9, right? Okay. So yes, in this case, the machine is faulty. Now that's just a made-up example, but it is an example where a company would actually use standard deviation to figure out if they need to adjust their manufacturing somehow. Okay? Now, here's a good one here. I don't think I made this a clicker, did I? No, I didn't. This is the last question before I give you guys a bit of an assignment. Which one of the following histograms, we talked about histograms the other day, has the higher standard deviation? I'll give you a second to think. Which one of the following histograms has the higher standard deviation? Which one has data that is more spread out? It's A or it's B? No, I didn't put it on the clickers. How many people say it is A? A has the higher standard deviation. Show of hands. Old-fashioned way. Nobody. How many people say it's B? Show of hands. Higher standard deviation. Well, my friends, the correct answer is...
You didn't answer.
Okay, let me show you. What does this data set show? It shows how many ones? 4 ones. So it's 1, 1, 1, 1, and then 2, 2, 2, 2, and then 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6. 6. The numbers are pretty spread out, aren't they? What's the data set look like here? It's a couple of 2s, then it's 3 3s. How many 4s? 6 4s. One too many. Okay. 3 5s and a couple of 6s. This one, there's way more data that's near the middle. Okay, they are close together. There's no 1s at all. This one has 4 1s and 4 6s. It has just as many 1s as it does 2s and 3s and 4s and 5s and 6. In fact, this is what we call a uniform distribution, right? This one is very spread out. So how can you tell? You may have seen me draw this the other day on top of things. Okay? Hang on, Brad. Let me get through this here, okay? When it looks like that, then this is a low standard deviation. When it's got a big bump in the middle, what does that mean? It means there's a lot of data at the middle. When it's got the high peak, that means there's a lot of data in the middle. When it's low, like this one straight across, if I drew a low curve like this, what does that mean? That means there's not as much data in the middle, and there's lots of data here and lots of data there. It's spread out. So the standard deviation is how high that curve thing is. Okay? And those of you that are jotting that down, good for you, because that's going to come in handy on the test.
Yeah.
Go ahead, Brad.
Do you make good pie? Because Ms. Moffenbauer makes French toast with her advanced.
Oh.
Every Monday morning she makes a French toast.
Really?
So funny.
Hmm. No, I don't make good pie. Maybe cookies. No, she doesn't.
Yes, she does.
No.
You want me to ask?
No.
You know, when you make